this video, I want to talk about what it means to be a function. So the simple definition in words is, if it is a function, each input goes to exactly one output. So each input, this is our x values, all right? Inputs are our x values, goes to exactly one output. Output is our y values. So this is kind of the more simple definition. You may see a more complex definition that looks a little bit like this. So in a relationship between two variables x and y is a function of x when each value of x goes to exactly one y. So we just kind of, in our more simple definition, we just kind of focus on this part. Each x corresponds to exactly one y. So how we'd want to use that is if you have a question phrased like this, is height a function of time? That's when we need to go back and think about this first part of the definition, right? Is height a function of time is really like y is a function of x, right? So what this does is it tells us which variable is which. So y is a function of x when, so that means that this height, in this case, would be my y or my output, and time, in this case, is my x or my input. Right? And now once we figured that out, then we can think about this second part. So if this is a function, each value of x corresponds to exactly one y, so each value of time corresponds to exactly one height. If that's true in the given situation, then it is a function. If it is not true, then it is not a function. So that idea might take a little time to digest. So if you need to pause, if you need to listen to that again, I highly recommend doing that. So now we'll look at a couple different situations where we can see and think about functions. So if we're looking at this diagram on the left, we're thinking about, is this a function? Does this represent a function? So we always want to go right back to that definition, right? Always right back to this. Does each input go to exactly one output? Does each x go to exactly one y? So in this case, I just want to look at each input. Okay, so this top one does go to exactly one, right? They all go to exactly one output. This is the situation that can get a little confusing sometimes. It's okay if each input, I should say if more than one input goes to the same output. This is okay. All we're worried about is if each input goes to exactly one output. So yes, this is a function. It does fit our definition. If we go over to our next example, I would encourage you to pause, see if you can look at this and figure out whether this may or may not be a function. There are actually two reasons why this is not a function. So one of those reasons has to do with this 4 and this 3. Okay, remember, our definition says each input has to go to exactly one output. So neither of these have an output at all. Right? So that does not fit our definition. Each input does not have an output. Also, 5 is an input that has multiple outputs. So this is what that looks like if one value is going to multiple other values. So my input of 5 has an output of 4, 5, and 7. So two reasons that is not a function. Moving on to graphs. It can be helpful to remember what a graph is, how it represents an equation. So in a graph actually represents all possible solutions to some equation. Okay. So this circle is a representation of some equation. The equation would actually look something like this: x minus 3 squared plus y squared equals, my radius is 3, 4, 5, 8, 2, so 2 squared. So this equation would represent this circle. And every point on this circle is a solution to this equation, meaning that the x and y values of any point, so this has an x and a y, x and a y, x and a y, if I plug those in to my equation, it will make it true. And that's what a graph is. So if we're thinking about whether or not this is a function or not, with a graph, well, again, we want to think of, does each input or each x value, these are my x values, does each input correspond to exactly one output? And in this case, it does not. Right? So let's look at this point. If I have an x value of 3, we'll look at this one because this is nice. So the x value of 3, there are 2 points on this graph that have an x value of 3. This is the point 3, 2, and down here, this is the point 3, negative 2. So I have an input of 3 with 2 different outputs. So 3, 2 is a point on my graph. 3, negative 2 is also a point. Okay, this is not a function because I have one input going to more than one output. Okay? If we go ahead and look at our parabola, again, I encourage you to pause, think about this for a minute. Is this a function? Does each input, each x value, correspond to exactly one y? And in this case, it does, right? We could think of any value of x. So when x is 0, it only has this one y value. When x is negative 2, it only has this one y value. And this brings in, this is a good place to bring in this idea of a vertical line test. Okay, so if we make some vertical line, if I make this vertical line and I kind of think about passing this through, oops, I got 2 vertical lines on here. I only want one. Let's get rid of this one real quick. And this is the one I want. Okay, so if I think about taking this vertical line and passing it through my graph, it is a function as long as it never crosses this graph at 2 points at one time. Okay, that sounds a little confusing. Let me try restating that. So as I pass this through, okay, if at any point this vertical line crosses the graph at more than 1 point, that it is not a function. Okay, and that's not the case here, right? There is no point on this graph where a vertical line will cross it twice. Okay, and that helps me see that there are no x values that go to more than one y. If I go back to my circle, notice that it does. There are tons of places, like basically every spot on this circle, except for the very ends, right? The vertical line will cross it twice. So that lets us know this is not a function. The parabola is a function. So we'll say, yes, this is a function. Each x goes to exactly one y. Okay. Moving on to tables. Hey, again, take a minute, take a look. We're looking at inputs and outputs. Does each input, and our x values are our inputs, does each input go to exactly one output? So if we look at our first table, the spot that we're looking at is this right here, right? So I have 2 that goes to 3, so an input of 3 and input of 2 with and an output of 3. I also have this spot here, an input of 2 and an output of 15. So that represents, we could think of this as 2 points, 2 comma 3 and 2 comma 15. Right, so I have one input going to more than one output. This is not a function, not a function. If we go down to the second table, again, I focus on these inputs. Right? These are all different numbers. They all have an output. So we're okay. This is a function. It's okay, remember, that 10 has an output of 4 and 11 has an output of 4. That's okay. We only are concerned if one input has more than one output. So yes, this is a function. Okay. Final piece, we're going to look at notation a little bit. Okay, so it's helpful to remember when we're looking at function notation, what is our input and output? So the input is going to be whatever's in here, right? Whatever is in the parentheses, we say f of x. So if I have an input, it's going to go in here. So if we look down here, for example, if we input 3 into our function, that's the same as saying x is 3. It's an input of 3. Okay, so we would be asking what is f of 3. And then whatever comes out is over here. This is our output. And so if we're looking at this function, say f of x equals 2x plus 5, and we're wondering what is f of 4, okay, that's saying if I have an input of 4, if I input 4 into this equation for x, okay, so f of 4, this is the same as substituting for x in our equation. So 2 times 4 plus 5. So if I input 4, what is my output? So f of 4, 2 times 4 is 8, plus 5 is equal to 13. So we would say f of 4 is equal to 13, where 4 is my input, 13 is my output. Similarly, if I tell you, so now in part 2, I'm going to ask what is the value of x, right? So what is the input if my output is 25? Okay, so f of x is 25. I want to know what is the input. So I'm giving you an output. So f of x is 25. If we start with this same equation, f of x equals 2x plus 5. I'm telling you f of x is 25, so I just substitute that 25 for f of x and solve. So 25 is equal to 2x plus 5. And now to solve, subtract 5 from both sides. 20 is equal to 2x. Divide by 2. And we see that x is equal to 10. And so if I wanted to rewrite this in function notation, we would say that f of 10, because we found that's my input, so when x is 10, the output is 25.